Welcome to the Deep Dive. Today, we're digging into a really fascinating set of notes from a veteran software developer, a real software plumber, you could say, someone who works deep in the architecture of code. And we're going to focus on their work in the Haskell ecosystem, specifically something that can make or break any project in the long run: dependency management. Our mission is to see what really happens, when you add just one library. It turns a fuzzy idea like dependency creep into something you can actually see and measure.
It's so critical, and it's something a lot of us, we just don't think about enough. We focus on our own code, the elegant parts, but we kind of ignore the huge infrastructure we're building on top of. So using these notes, we're going to look at a project built with the Stack tool and really unpack those relationships, see what that structure tells us about maintenance and, frankly, project headaches down the road.
And the tool that unlocks this whole thing for them is one command line instruction. It's like an X-ray for your project.
Yeah.
Stackle's dependencies tree. They even note it's basically the same thing you'd see in the Elixir world with a mixed deps.tree. So that visualization, that's our starting point for understanding the real cost of complexity. Okay, let's unpack this then. We have to start with a baseline. What does a brand new, totally clean Haskell project even look like before we've added anything? The analysis here starts with a fresh project. It's called XS2 ebook 0.1.0.0. It's as simple as it gets, and that gives us a really clear picture of what minimal means.
Right. This is the absolute DNA of a Haskell application. The project itself, XS2 ebook, immediately depends on one thing: base 4.2.8.2.0.
The standard library.
Come to your library, yeah. It has all the basic types, the common functions you'd expect. But the interesting part isn't base itself, it's what base depends on. That's where the story begins.
Okay.
So you follow that tree down just one level, and you see base relies on GHC internal 9.1003.0. Now that name alone, GHC internal, it tells you it's tied very, very tightly to the compiler. And that's where things get sensitive. Sensitive how? I'm looking at the notes. And that GHC internal quickly pulls in GHC bignum 1.3, and then that links to arts 1.0.2. So why is the runtime system so important in this little family tree?
The RUTS it's basically the virtual machine for Haskell. It's the engine. It handles garbage collection, scheduling threads, all the really low-level stuff that lets your program actually run.
So it's the absolute foundation.
The deepest layer. And when your dependency list is this clean, you have this tiny, really tightly controlled family. A change to the arts, even a small version bump, can have huge ripple effects all the way up.
So this initial state, it's perfect, it's optimized, it's minimal. You can hold those 3 or 4 components in your head and know exactly what you're dealing with.
Exactly. You have total control. The notes describe it perfectly, calling it a clear glimpse into the core engine. It's just enough to get a program compiled, and this is the standard we're going to measure everything else against. And here is where it gets really interesting. This is the big aha moment in the notes. Yeah. This is what happens when the developer adds just one very common, very useful package: optparse-applicative.
A classic. For parsing command line arguments.
Right. And the change is, it's dramatic. The author says the dependency count increases substantially. The whole project goes from being a little sapling to a thicket. So why? Why does adding one thing, just for parsing arguments, pull in so much extra stuff?
Well, it's because a good modern library like that isn't just solving a narrow problem. It's not just parse these flags. It's solving the bigger problem of create a robust, user-friendly, cross-platform command line interface. And to do that well, you need things like color in your error messages. You need efficient ways to handle text. You need to talk to the operating system.
And all of those things are their own libraries.
They are, and they get pulled in as secondary dependencies. I mean, look at the list here. For color, you get ANSI terminal and color. For handling data efficiently, you suddenly need byte string and text.
And then for talking to the OS, I see process and Unix on this list. Or Win32 if you're on Windows, I suppose.
Exactly. So your simple tool now needs to know about file paths and operating system processes.
That's already a big jump, but the list goes deeper. I'm seeing packages like MTL and transformers. These aren't just for command line flags, are they? That sounds more structural.
No, you're right. They're not. Those are fundamental libraries for managing state and effects in functional programming. For monads, optparse-applicative uses those powerful structures for its internal logic, which is what makes it so robust.
So by adding this one convenient tool, you're implicitly signing up to support its entire architectural philosophy.
You are. You're now on the hook for making sure all those versions, for state, for time, for concurrency, all play nicely with each other and with your compiler.
This is where I start to see the real cost. It's not just about the number of packages, it's the ongoing work. You're not just adding one library, you're inheriting the work of dozens of other development teams you now have to trust. So if we connect this to the bigger picture, what are the actual long-term consequences of this dependency sprawl? Especially in a language like Haskell, where a tool like Stack is so strict.
That's the heart of it, isn't it? With the stack, you're working with these strict snapshots. So if just one of those, say, 30 new packages has a security flaw or a version conflict, your entire build stops. It just grinds to a halt.
Until you can find a combination that works across the whole graph.
Right. And the implication is really threefold. First, you've got security. Every single package is a new door that could have a vulnerability. You have to watch all of them.
Okay.
Second is what I'd call compiler friction. When a new version of GHC, the Haskell compiler, comes out, you have to find compatible versions for all 30 of those packages. The more you have, the more likely one of them is going to hold you back because it's not maintained anymore.
And the third?
Build times. Plain and simple. More dependencies mean more fetching, more compiling, more linking. It slows down your whole development loop. That hitting wait is literally slowing you down every single day.
It really makes that first minimal dependency tree look like architectural gold.
Yeah.
It just hammers home that idea that every line of code you didn't write is code you now have to maintain. But this brings us to a fascinating paradox in the notes. We've just established that optparse-applicative creates all this sprawl and debt, and yet the developer still highly recommends it for robust tools.
Right.
So wait a minute. You'd highly recommend a package that immediately triples your workload. Doesn't that go against everything we just said about simplicity?
It does seem like a contradiction, but it's really about the core tension in engineering. The developer is making a distinction between, let's say, architectural purity and developer ergonomics.
Ergonomics, meaning how easy it is to use.
Exactly. For the developer and for the end user, this external package gives you things that make your life so much easier and make the final program feel way more professional.
Like what? What are these must-have features?
Well, the notes point to a few. Automatic help text generation, so your documentation is always up to date. Really high quality, helpful error messages. And maybe the killer feature, support for shell tab completion.
Okay.
If you're building a tool that people are going to use from the command line all day, that's not a nice to have. That's essential for a good user experience.
So the trade-off isn't just about adding features, it's about the quality of the user interface. You take on the architectural debt because it buys you a much better experience if you can manage that debt.
And that if is the key. The mitigation is crucial here. They didn't just add the package blindly. They took the time to review that whole tree and, as the notes say, confirm that everything was actively maintained and up to date.
It's an informed choice.
Yeah.
It's fine to take on complexity, as long as it's healthy complexity.
Precisely. Now, contrast that with the alternative they mentioned, system.console.getOpt. It's a standard library module. It's been around forever, usually bundled right with the compiler.
And this one is preferred for simpler tools.
Right. And there's a real philosophy behind that choice, which comes through in the notes. The author has a general preference for sticking to standard libraries whenever possible.
Why?
Because if you can get 90% of what you need from the standard tools, you completely avoid that exponential growth in tracking and security audits and compiler friction we were just talking about.
This really sharpens the focus on the developer's whole mindset. This isn't just about code. It's a statement about self-reliance, about controlling your own environment.
It is. By choosing system.console.topt for the simple stuff, you are actively choosing simplicity. You're choosing to reduce that maintenance load over grabbing the easy, convenient external package.
And that connects to the bigger picture of their work, doesn't it?
Yeah.
The notes show this person is obsessed with documenting everything and being self-sufficient, whether it's gardening or code.
It absolutely does. Choosing a standard library over an external one is a form of project self-reliance. Your fate is tied to the core compiler team, not 30 different maintainers scattered across the internet.
That's a powerful way to look at it. It's not a tactical choice. It's a strategic one based on your values.
And to summarize that trade-off for you, the listener, an external library like optparse-applicative is a great choice when your project needs those advanced features, like auto-documentation or great ergonomics, but only if you do the work to vet its dependencies.
But if your needs are simple.
If your needs are simple, maybe you just need to handle two flags, a standard library like system.console. GetOpt will dramatically reduce your long-term headaches. It's about choosing the right tool for the job's complexity, not just the shiniest tool available.
It makes you realize the most important command isn't the one that builds the code. It's the one that shows you the structure underneath it all, that Stackle's dependencies tree. So what's the big takeaway here for developers? This deep dive really confirms that visualizing your dependencies is, well, it's essential. It shines a light on the true, hidden cost of adding a package and forces you to balance that short-term convenience against the long-term complexity.
It's really an argument for architectural mindfulness. You have to look under the hood before you hit install. You have to ask, is the convenience I'm getting today worth the commitment I'm making to this whole extended family of code? And that lesson is true everywhere, whether it's Haskell or Python or anything else.
And this whole philosophy, the meticulous documentation, the dependency tracking, favoring stability, it seems to reflect a much broader worldview. I mean, the source material shows this person is deeply committed to things beyond code. They document their life, hundreds of posts on fish keeping and gardening, and critically, they actively support FOSS projects.
Yes, projects like the Electronic Frontier Foundation and the Tor project.
Right.
And that personal ethos of understanding your foundations, of documenting everything, maximizing your own freedom, it's clearly reflected in their code choices. The whole FLOSS movement values transparency and the ability for users to control their own tools.
And relying on fewer standard components makes a project more stable, more auditable.
And easier for the next person to take over, or even your future self. It's about maintaining that control. And this leaves a really important question for you, the listener, to think about. How does this dedication to self-reliance and complete personal documentation reflect the philosophy behind favoring simpler, standard tools when possible? What deeper value is being placed on simplicity and intellectual freedom in the open source world, and how often are our technical choices secretly being driven by our philosophical values? That's something to think about the next time you're about to add a new library to your project.